All right, chapter 20, testing hypothesis. About proportions. A hypothesis is a working model we adopt temporarily we always assume no changes. So our null hypothesis which will denote H sub 0 usually states that there is no change or effect H sub 0, the null hypothesis, is the parameter or the hypothesized value such as the null hypothesis is P is equal to 0.20. Then we have the alternative hypothesis, which we do as H sub A contains the values of the parameter that we consider plausible if we reject the null hypothesis. So for example, the alternate to this null could be a couple different things. It could be P is greater than 0.20. It could be that P is not equal to 0.20, or that P is less than 0.20. The standard deviation of the sampling model is standard deviation of P hat equal to the square root of PQ over N. Alright, this next thing is important. Not that the rest of it isn't, but we are trying to see if there's enough evidence to show that our null hypothesis is false. We never prove the null hypothesis. To be true. We only show that it is false, or there is not enough evidence to show that it is false. So when you think about this, think guilty versus not guilty. So we either reject or we fail to reject. If we reject, then there is enough. If we fail to reject, there is not enough in terms of evidence. Our calculations will answer the question, what is the probability of getting our observed results or something less likely given that the null hypothesis H sub 0 is true. This probability is called the p-value. If the p-value is high, we haven't found anything surprising. Or unusual. If the p-value is low enough, it says we are unlikely to see our observed results if the null hypothesis is true. So it may cause us to reject the null hypothesis if we don't reject, we say we fail to reject. the reason of hypothesis testing one, we have our hypothesis. So what we have to, this is kind of how we go about it and what our problem, like our answer solution will look like. So first we state the null and alternative hypothesis. So we would have a null, which would say that P is equal to P hat. So this is the hypothesized value. Assume no change. Then we have our alternative hypothesis, which says that either P is less than P hat, P is greater than P hat, or P is not equal to P hat. And this is what we are trying to prove. So then we model it. And this should include something like, because the conditions are satisfied, I can model the sampling distribution with the normal model N of mu and sigma. So we use the one proportion z-test. Or it'll be called one prob z-test on your calculator. So the h sub 0 is P is equal to P sub 0 or P hat. The test statistic is Z is equal to P hat minus P0 over the standard deviation of P hat, where the standard deviation of P hat is equal to the square root of P sub 0 Q sub 0 over N. And we use the normal model to obtain a p-value. And don't be too alarmed, your calculator does most of this for you. So then my next thing are the mechanics. Which are to calculate the p-value using the appropriate test. And 4, we make a conclusion, or we have a conclusion. Yeah. Where? Okay.
I just started
No.
too.
My voice could take a pause anyways. Yeah. We're almost done, if that's what you're wondering. There's just a little bit more after I do the conclusion part. All right, so for the conclusion, make a statement. Based on the p-value and state either reject the null hypothesis or fail to reject. Always in context. So don't just be like, I reject the null hypothesis, like explain why. So by that, be sure to answer the actual question that began the testing procedure. It is usually good to include a confidence interval within or with the conclusion. Meaning like the 90% or whatever, how confident we are. So in terms of deciding the appropriate test from the mechanics part, I'm going to go into that a little bit more here. For the alternative hypothesis, think about each test. Do you want to know if there is any change increases or decreases? And then depending on that helps you choose which test. So I'm going to do 3 separate little curves here. I'm going to write something under each of them. So this is our P0, the mean value. So then I'm going to draw each of the scenarios and then explain what they mean. So this first one where you have something on both ends, your alternate hypothesis would be P is not equal to P0. And it's what we call a two-tailed test. This one where it's only on the right side, the alternate is P is greater than P0. The one on the left is, or where it's on the left, is the alternate is P is less than P0. And so these ones we say are one-tailed or one-sided. But specifically this first one was right-tailed. The other one was left-tailed, which is usually how we'll refer to them, because one tail doesn't tell you which side. So then just a note about this, a one-tailed test will reject the null hypothesis more often the one-tailed p-value is half the two-tailed p-value. Because obviously, like, the right tail would just be this side of the two-tail, and then the left tail would be just this side of it. So that's where that comes from. And that's all the notes for that. You don't have to listen to my horrible